some basic shapes. As in this figure, there are squares and there are rectangles galore all over the place. And shapes become part of what we see in the world, so they're a big part of the study of geometry. And in this case, shapes are built by joining segments, lines, and rays. For instance, if I join two rays, like in this case, ray BC and ray BA, is ray AB the same as ray BA? No. Ray BA means you start at B and you go through A. So if I join ray BC and ray BA, I create what you call an angle. Okay? And there's another one right there. So when I put the shape of a ray ABC with the shape of a ray AB, you could think of them as two distinct rays, except when they join up at the common point of B, we consider that a single shape now called a angle. And there's a few different ways to name it. We could say angle CBA or angle ABC, or we could even call it angle B. But if I go a step further and I draw another line across those, I create a piece in the middle, if I limit it to just the line segments, that create a triangle. Namely, there's my three symbols, or my three line segments that create triangle ABC. So we can create all of these sort of shapes by joining rays and lines and points. Here we start with angle ABC again. And this time we add two line segments or lines or rays, it doesn't matter which. And you'll see that we create now not a three-sided triangle, but a four-sided quadrilateral. Okay? So here's the basic shapes that we're going to study. We're going to study triangles. We're going to study quadrilaterals. We're going to study also trapezoids and so on and so forth. We'll study into many sided shapes as we go through the semester. As for coordinate geometry, we're going to be sure to study slope, midpoint, and distance formulas in depth and how to apply them to these figures. So let's start with some basic shapes, like, for example, triangles. And there are two ways to classify triangles. One way to classify them is by the lengths of their sides, and the other is by the measures of their angles. If all three sides are the same, then we call it an equilateral triangle. If two of the sides are the same, we call it an isosceles triangle. Now let's look at these root words so they're easy to remember. A lateral is a side. Like, for example, in football, if you throw the football sideways, we call it a lateral. Or the ligament on the outside of your leg is called the lateral collateral ligament. Well, equilateral means equal sides. So when all three sides are equal in the triangle, it's called an equilateral triangle. An isosceles triangle has two equal sides. Iso means same, scale, scale. So same scale, that means two sides are the same. And a scalene triangle has no equal sides. So those are the ways of representing or classifying triangles by the lengths of their sides. If we want to concern ourselves with angles, just like we had equilateral for equal sides, we have equiangular for equal angles. In this case, all three angles are 60 degrees because, in case you remember, the three angles of a triangle add up to 180, and if they're all equal, I divide by 3 and I get 60 each. An acute triangle has three acute angles. A right triangle has one right triangle. My students famously called this a Lindquist triangle, even though I make a sloppy mistake or two every day. And an obtuse triangle has one angle that's greater than 90 degrees. So a right triangle has one 90-degree angle. You cannot have more than one. We'll talk about that at another point in time. It's actually a really famous part of Euclid studies. An acute triangle has all three angles less than 90. A right triangle has one of 90, and an obtuse has one that's greater than 90 degrees. Okay. So here's your examples again. If we look at classifying it by angles or sides, if we do by sides, I have equilateral, all are the same. A right triangle has a right angle in it. That's based on an angle. Isosceles has two equal sides. Scalene has all different sides are equal. By the way, a right angle or a right triangle can also be scalene because the sides could be not equal, or it could be isosceles. They could be equal. So look at these and try to classify them as best you can, what each of these types are. We will do stop and start, and I will fill in the blank in just a moment. Go ahead. Okay, the first one is scalene because all three are different sides. The second one, directly underneath it, well, oh, we went to the upper right. I'm sorry. That would be scalene and right. It's definitely a right triangle because of the 90-degree angle in the lower left corner here. And the sides are not the same, so it's scalene. Now number two, which was underneath. We're going to go with scalene there. It looks like the side on the right is a little shorter than the side on the left. If you thought they were the same and went isosceles, this isn't a perfect measurement, so I would understand why you did that. Number six, we have isosceles. You can see that the two sides pointing up, we call those legs because in an isosceles triangle, the legs are equal. Those two sides pointing up, these guys right here, they're the same length. What about number three? Well, that would be equilateral because they're all the same. Number seven, well, we see that there's that right angle there, so it's definitely right, and those sides don't look the same, so it's right and it's scalene. Number four, looks to me like we have isosceles there. Okay, and number eight, that would be obtuse, but it would also be scalene. Okay, equilateral would also be acute. So this scalene up top would have one obtuse angle, and so on. Let's do some more. Okay, label as scalene, isosceles, equilateral, acute, right, or obtuse, or more than one term for each diagram. Little stop and start. Go ahead. Okay, so these marks here are meant to tell you that these sides are exactly the same, and this little symbol in the corner means it's a right angle. So the first one would be isosceles and right. So you should have done all of these, so which order I fill them in doesn't really matter. Then we have scalene and right, because the sides are not the same. This is scalene and obtuse because that angle up top there is greater than 90. Then we have scalene and acute. If you thought that this was isosceles, I could understand that. I think the leg, if you will, I'm using that term very loosely, on the left here, the side on the left, I think is a little shorter than the side on the right. But if you thought they were the same and you went with isosceles, I'm okay with that. See, the reason I didn't is because they seem to mark every time it's isosceles. So this one over here is isosceles and right. Down here, scalene and right. Over here, we know this is isosceles because of the marks, and it's also obtuse. Down here, same thing, isosceles and obtuse. And then last but not least is equilateral. It's also acute. Okay, now the happy recap all about triangles. So I am a New York Met fan, and Bob Murphy used to be the announcer years ago, and every time the Mets would win, I don't need any comments about how that never happened. Every time the Mets would win, he'd say, and now for the happy recap. Just remember, when we classify by sides, I could have no equal sides, 2 equal sides, or 3 equal sides. 3 is equilateral, 2 is isosceles, none is scalene. And with angles, I can have all 3 angles the same, which is equiangular. I can have an acute, which is 3 angles all less than 90. I can have 1 angle of 90. That would be a right triangle. And I can have an obtuse, which is 1 angle greater than 90. So that's your basic shapes and everything you need to know. The end of lesson 1, we got around 30 more of these to go with a handful of tests put in there, 3 or 4 tests along the way. All right, I hope you guys enjoyed the class. It's just the beginning. It's going to get way better than this. Take care and enjoy. Bye-bye.